In the next exam question, we have a competition where participants must attempt to throw a ball vertically upwards past a point T, as marked on the vertical pole. Point T is 3.7 meters above the ground. Point T may or may not be the highest point during the motion of a ball. One participant throws the ball vertically upwards with an initial velocity of 7.5 meters per second from a point that is 1.6 meters above the ground. Ignore all effects of air resistance. From the information given, we can see that we have an initial velocity of this ball of 7.5 meters per second. The ball will move upward until it reaches its highest point somewhere before T, at T, or after T. Now at this stage, we do not know where exactly the velocity would be zero, but we do know that when a ball reaches its highest point, the velocity is zero. In question 3.1, they then ask, in which direction is the net force acting on the ball while it moves towards point T? Choose from upwards or downwards and give a reason for your answer for a total of 2 marks. Looking at the free body diagram of our projectile, we can see that only gravity is working in on it. Therefore, the net force acting on this ball is equal to the gravitational force, which is in the downward direction. Three point two says calculate the time taken by the ball to reach its highest point for a total of 3 marks. In this problem, we are asked to calculate the time it takes to go from an initial velocity of 7.5 meters per second to a final velocity of 0 meters per second. Looking at our equations of motions, we can see that we can use equation 1. We have the final velocity of 0, the initial velocity of 7.5, the constant acceleration of 9.8 in the downward direction, and in this problem we will take down to be negative. Which gives you a total time of 0.77 seconds. Question 3.3 says, determine by means of a calculation whether the ball will pass point T or not for a total of 6 marks. In this problem, we are asked to determine the height that the ball will reach from its initial position to its final position where the velocity is equal to 0. To solve this problem, we can either make use of equation 2 or equation 3, seeing as we have all the variables and we are looking for the change in position. From its starting point to its final point, my ball then reaches a height of 2.87 meters. So the height that the ball reaches above the ground will be the sum of the 2.87 and the 1.6 meters. Which gives you a height of 4.47 meters. Point T is only 3.7 meters above the ground, and therefore this ball will move past point T. Three point 4 says draw a velocity time graph for the motion of the ball from the instant it is thrown upwards until it reaches its highest point. Indicate the following: the initial velocity and the final velocity, and the time taken to reach the highest point for a total of 2 marks. For this velocity time graph, we are only asked to draw the upward direction of our projectile. Here we have an initial velocity of 7.5 meters per second. It reaches its highest point where the velocity would be equal to 0. And this projectile motion takes a total time of 0.77 seconds. To draw the velocity time graph, I simply make use of the information that I have. I have the initial velocity in the upward direction of 7.5, and my ball then reaches a final velocity of 0. The time that the ball takes to reach its highest point is equal to 0.77 seconds.